trying to make this as painless as possible. So what better way to do that than to turn myself into a pickle? Yes, I am losing my mind, but that is a-okay. So we're going to start talking about proving triangles congruent using the side, 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 and side angle side postulate. I can just imagine everyone who's not in my class watching this. Welcome. Glad you're here. So first of all, side, side, side congruence says if three sides of one triangle are congruent to three sides of a second triangle, then these triangles are congruent. That's the basic definition of congruence that we've talked about since elementary school. However, side angle side congruence says if two angles and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. So the important piece right here is included, because if you're not focused on the included angle, you then have angle side side, which is not a thing for some reasons that may or may not be obvious to you. But if you abbreviate, you could probably figure out why. So this angle in between the sides that we've already listed to be congruent to each other has to be congruent as well. Then we can show that in this case, triangle ABC is congruent to DEF using that side angle side congruence. So that's the background here. In my class, you guys should have this in your chapter 6 glossary. So we're just going to start by writing proofs. So this is example 1 here. Okay, so this is example 1. We are going to write a flow proof, which my class, if you can show me whichever way you want, you can write a flow proof, a 2-column proof, or a paragraph proof. That's all up to you. I just want to have you guys list out the logical steps and reasonings to prove each thing. So I'm going to go off of what a flow proof is. So I'm going to start with the given information here, and I'm going to list all of that out. So we are given, and I'm going to break it up into pieces. So we're given that GH is congruent to KH or KJ, whatever letter that is. What are you doing? Okay, this is given information. Okay, let's see if you'll box my, there we go. All right, another piece of given information is that HL is congruent to JL. This is also given. I'm loving that it does that because, oh man. And then L is the midpoint of GK. So we talk about this all the time. Whenever you guys have proofs, you always start with the given information, listing out everything we know. Okay. The next piece, we need to figure out what we need. So I'm going to mark this image here. I'm going to say GH is congruent to KJ, and then we have HL and JL. So this is 2, this is 2. And then we know that L is the midpoint of GK. So because L, first of all, I need some more information on this. What does that mean? L is the midpoint of GK. That means that L is located directly in the center, which says that these pieces are broken up into half. That tells me that GL is congruent. I just got a glimpse of my pickle picture. It's congruent to KL. And how did we get that information? Oh, I don't want to put a fancy box around that. We got that information using the midpoint theorem. The definition of midpoint. The midpoint theorem says if you have something that is the midpoint, it creates two equal or two congruent segments. So now that we have that, well, looking at our image, we have 3 sides that are congruent. So here's a side. Let me label this. Here's a side. Here's a side. Here's a side. So now that I have 3 sides, they're going to all come together into our final proof of GHL, triangle. GHL is congruent to triangle KJL. And we figured that out given, oh, good, side, side, side. I like flow proofs when we talk about these side, 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 angle, side, angle, angle, side, all of those things. I like the flow proof because I go back and label the information that I know. Like I did here with this red, you know, I see that this is a side, this is a side, and this is also a side. So SSS, side, side, side. There's example 1. So if you guys are following in the textbook, this is technically example 3, but we skipped a section that we just didn't have time for it, and I don't want to get into it, so I'm skipping example 2 in this. So if you're following along in the book, this example can be found on page 356. Okay. So this one says the scaffolding for stage lighting oh my goodness, let me start over. The scaffolding for stage lighting shown appears to be made up of congruent triangles. It appears that way, but we have to prove it. If WX, so I am going to go through here, WX is congruent to YZ. So here's WX is congruent to YZ. And WX is parallel to ZY. Write a 2-column proof to prove that WXZ is congruent to YZX. Okay, so a couple things here. If we can go with the 2-column proof, we can go back to the flow proof if you'd like. I'm going to just do a 2-column real quick here, and I'm going to start that off by saying, you know, my given information, so statements. You know, I'm going to pause this, and I'm going to type this up because I'm a cheater. Okay, statements and reasons. So the first statement we have is WX is congruent to YZ. And that's given. So there's one. We also know that WX is parallel to ZY. That's also given. So from the fact that these two are parallel, we can kind of come up with a couple things. We see that there's this parallel. Let me try to, okay, I'll just draw on top of it. There's this line is parallel to this line, and we have this right here going through it. That would be considered our transversal. So from that information, we can prove, or we know, this little angle is congruent to this little angle right here. And the reason we know that is because of alternate interior angles. So we have WXZ, angle WXZ has to be congruent to angle, let's see where I'm at, YZX. And that was alternate. You'd think that my handwriting would get better, but you'd be wrong. What else do we know about this? We know that XZ and XZ has to be equal to itself. And that's the reflexive property. So now going through this, I have, here's a side, here's an angle, and here's a side. And before I assign this side angle side, even though it's listed in that order, I want to make sure that I have the inscribed angle is the one we're talking about. And that is true because this angle up here, this WXZ, is in between the two pieces, the two sides that we talked about. So yes, this last step, we can say that triangle WXZ is congruent to triangle YZX using side angle side. Okay, so this last example says to write a paragraph proof, but I'm not about that. So we're just going to write a proof, whichever way you are comfortable with. However, I'm going to show you the flow proof, okay? So we're given BC and DC. BC is congruent to DC. And you guys, if you are going through and you want to check and you send me a paragraph proof, I'll still read it. I just don't prefer to write them. So this is given BCF is congruent to angle DCE. That is given, needs to do that on every single one. And then we know that FC is congruent to EC. So we are given quite a bit here. We're given a side, an angle, and a side, but I haven't quite looked at where those lie yet. And our goal is to get down to where angle CFD is congruent to angle CEB. Okay, so CFD. So I'm gonna, here's our goal. That's what we're trying to get to. So I'm gonna highlight that CFD. So this angle up here, we want to prove that it's congruent to this angle right here. Okay. So, well, we do know a couple things. From all of the given pieces, we know that triangle BCF is congruent to triangle DCE because of side angle side congruence. So all of these pieces kind of came together to show us that those two triangles are congruent. However, we're looking for CFD and CEB, which aren't in those triangles. Something else we can go off of, and this might, take a little bit more, but we have the fact that, so from here, okay, let me gather my thoughts here. We can see that angle BFC is going to be congruent to DEC. And stick with me here, you guys might not see, I'm going through some processes. We have these two angles right here are congruent, okay? So we know that. So this would be corresponding parts of congruent triangles. Okay, we may have mentioned that before, but since we know that those two triangles are congruent, their corresponding parts are also going to be congruent. From here, and watch this, because here's a magic trick, I can jump to here. I can say, well, because I know BFC is congruent to DEC, I know that these two are congruent. And if you guys, again, want to pause and think about how the heck did she get that, I can go and say and this is in Unit 6 still. We did talk about this a couple sections ago, maybe last section, actually. No, a couple sections ago. The congruent supplements theorem. Congruent supplement theorem shows us that CFD is congruent to CEB, and this is how you solve example 3. And see, I did it as a pickle. Yeah, it's not funny anymore, I know. Email me with questions. You guys are rock stars. Don't forget it.